rolling right along, right into our final speaker for the day. We've got Sudhir Chepeni, Director of Products and Technology at Akamai. And he's going to be talking to us about exploring advanced API security techniques and technologies. Take it away, Sudhir.
Thank you so much. Can you see and hear me all right? Trish? Yeah, okay, great. Thanks. So my name is Sudhir. I have like 20 years experience in technology. And today what you're talking about is we hear about a lot of API security. So I want to level set like what we are seeing at Akamai and in a way have a conversation. Or when we talk about API security, it means different things to different people. If you're a developer, API security is different. If you're operating a DevOps team, you're talking about different set of problems altogether. So the way we're going to frame the conversation is, why we are doing it, the intensity and how large the problem has become, and then get into see some of the things we can do it. So even though I work for Akamai, this is not a product pitch, it's much more of a conversation where we want to explore what's out there and how you can protect your assets using APIs. So let's dig in. Uh, all right. So if you look at that, more and more modernization and digitization is causing more and more APIs to be utilized. For example, COVID-19, as you can imagine, overnight, all the offices which made coming to office required are totally remote. What that means is all the assets they were accessing in-house or your on-prem computers have moved to cloud. Digitization, more and more organizations have these policies and procedures where they want to move to the cloud or have the you know elasticity to expand their workloads at the same time provide the security. These skills is also an interesting problem because gone are the days when you had a SQL Server administrator or Oracle administrator who would get into the details and solving. Nowadays everything is cloud, and the ability to move from capex to opex for the organizations is much higher. And obviously, in all this, presumably there is cost saving because you only pay for what you use, which is always a great elastic combination you would like to have for any organization who's looking at the bottom line. So if you look at that, all of these reasons have accelerated the use of APIs. And when you talk about APIs, even the analyst community, if you talk about Gartner, Forrester, there's still a little bit in the gray area. When you talk about API, we talk about web applications which use APIs and also the API. That means that your headless call, you can do one transaction and you get a request response kind of model. So we all dig into that a little bit. So if you look into that, more and more applications are modernizing, as I was talking about, for all those reasons. And this is just a data I collected from Gartner and Smart Bear. 75% believe microservices will drive the biggest growth in APIs, and 80% of organizations are developing public-facing APIs. So that's a large number, if you can imagine, compared to anything we have seen in the past. So the idea is that you can build a business today without having the core capabilities. We already see that. If you have a payment, you have a Stripe integration, right? You don't necessarily have to write all the technology to make sure that your payment is processed properly to the bank. So all you need to have is an idea, and you can aggregate them or combine with the already well-known APIs to solve a particular business problem. And that seems to be the future of the world, and where ChatGPT and all the AI is transforming how we interact with each other and on the internet. What you would see is API will become a fundamental channel of exchanging data. And when you talk about impacting the developer team, your developer efficiency, your better connectivity, and rapid innovation also cause all the development tools think of use to do on-prem are going onto the cloud. So APIs everywhere, they're key enabler of digital transformation, and they are the key for strategizing the modern application. So next, I'll just so they can appreciate the intensity and the how big the problem is. So if you look at Akamai, of course, we can talk about some stats. We are seeing like a significant amount of volume increase on API. And similarly, not only us, if you look at other, these are well-known data sets outside in public domain. The idea is that the API problem is becoming bigger and bigger as we speak on every quarter, every year. And the reason for that is we already know, digitization, remote work, and all other aspects of innovations are our API today. And explosive growth in API requests is only outpaced by obviously when you have more APIs being exposed on the internet. you have your corresponding more chances of malicious actor taking advantage of it or exploiting into some of the things you forgot, or things happen. So that kind of thing. And all the indicators today, if you look at the analyst view, they all indicate that API security is going to be a big market. There's a lot that needs to be done. And if you have APIs today, you need to be aware of some of the things we'll talk in a bit. And this is just another stat. We at Akamai look at lots and lots of data. Just to look at that, 6 billion web attacks per quarter, that's a lot of attacks you would see. And you can just imagine, with more and APIs coming online, the the intensity of the problem is becoming worse. So what I'm trying to say here is, hey, there is this big problem. Everybody needs to be aware. The more APIs you're exposing to the world, the more vulnerable you are becoming, and you need to have a good strategy in place for API security, and that's where we'll get in detail. Similarly, the intensity of the problem is not just per one vertical. Hey, I'm a financial company, I don't have to worry about API security, or I'm a retail. So the problem is across all verticals. So if when we did some analysis for the Log4j attack, we saw that no matter which industry you take, the problem persists. And similarly, the attacks is global in the sense, like, all countries, no matter which geography region you are, they are susceptible to attack. So when you have APIs which are being exposed to the internet, you are no longer a local problem at this point. You are exposing your application and businesses to be exploited across the globe and across the verticals. That's what we're trying to communicate over here. And similarly, another key aspect which we do not spend enough time and should be very careful about is API security is not one and done. What that means is, hey, I found this vulnerability, I patched it, I'm all set. So a recent case study we did on Spring Core, what you would see is that there was this vulnerability identified. Obviously, the community jumped on it, took a immediate action, and they patched it. But very soon, if you look at the spike on your right, after a while, it again appears on a different flavor. So whatever solution and however you're thinking about API security, it shouldn't be like it's on a continuous horizon, if you will. The idea is that you have to have a full life cycle. That means you're constantly monitoring for new things. Even though you have patched in the past, it doesn't mean that the problem goes away. You still have to worry about it. You should have a strategy in place where you're looking at all your development environment, your runtime environment, to make sure that you have that full cycle visibility for making sure that you have the coverage. So all this leads to risk, right? If you look at that, modern application have more moving parts, pieces to manage. The nature of collaboration is evolving from local to global. Whenever you have an API online, that means around the world people can access that. And development trends are changing. You have more and more DevOps, DevSecOps taking over, and a DevOps team has more power. You can right now deploy application as infrastructure as a code. That means you go on AWS or Azure. You can code in a way that you can not only deploy the application, you can deploy the infrastructure as well. And teams are often using different tooling systems, and that's your always the risk factor. So the idea is that the world needs more functionality and more features, more users, and more data. And whenever you have a more problem, you always have to worry about on the adversaries. It is more data to go after for malicious actors to be on. And just as a fact check, you can see that almost twice the number of times a breach or external attack is done whenever API sector. So the API, so the more is also at the malicious attack side, where people are able to attack more significantly with all these modern tools to be able to infiltrate your organizations. And so if you look at that, I mean, what will happen? Obviously, significant damage to your reputation. You don't want to be in this, but I'm sure all of these organizations did the right thing, where they applied the policies, they made sure their practices in place. But API security is a different beast, in the sense that your traditional tools and techniques may not be able to give you the protection you're looking for across the board, right? So that's something you need to be aware. So when you are deploying new APIs, you should be conscious that, hey, I have my perimeter protector. That's not enough, right? So, I have my container scan. That's not enough. So whatever strategy you put in place, it's a combination of, a layered security model, which is you're not only monitoring, you're also actively, patching. So it's a combination of that. So if you look at that today, securing an application means, developing custom developed source code. That is very common. You see software that forms your supply chain. So chances are you're using some open source from somewhere which could have vulnerabilities. Maybe you did not scan it, so that causes some. And CI/CD pipeline itself, how you're building it, what latest containers you're downloading, or what kind of libraries you're pulling in to build that happen. So that could cause some exposure to your APIs. And similarly, infrastructure hosting the application could be compromised too. So API powering the common between user and their app is increasing, on a rapid pace. So next, so hopefully by this time I have established the fact that this API security problem is very big. It's not local, it's global. Customers want more and more abilities and capabilities to be delivered. And what that means is your risk for your organizations is much higher. So next few minutes, what I'm going to spend on is, how a typical API is built, and how to think about it, and then, how to provide an overall security strategy where you can feel that, you have the API security coverage. So if you look at quickly, in general, I don't know the audience, it's not level set so that we're talking about the same thing. So the application program interface is pretty straightforward. You have something, you need to get something, and the idea is that the important factor, what you need to worry about is both sides. It could be different programming language. Whatever X needs, Y could be in Python, and X could be in Java. So the idea is that you're exchanging information. And when you talk about exchanging the information, there are different types and, different stakeholders who are involved in your API transaction. There are different transport layers you need to worry about, the data encoding, infrastructure. So now you're getting into the details about what an API contains and what are the various moving parts within API you should be worried about, not just writing the code for a particular business problem. And then now, if you drill down further, you're getting into types of APIs. For example, you talk about public APIs, there are private APIs, there are partner APIs, and similarly, there are different protocols you utilize today to deploy APIs. For example, your SOAP, gRPC, GraphQL, most common is, of course, HTTP. And similarly, the deployment challenges are different. Some of them are deployed as virtualized services. Some of them, if you're cloud native, you're deployed on container. At the end of the day, everything is an API. So the idea is that when you're transforming or exchanging data between two systems, we all need to now worry about getting into the next level of detail of all these, what protocol and what are vulnerabilities to that, what kind of API. If it's public API, you need to have a little more cadence around them, and how it is deployed. So understanding the API types, protocols, deployment is key before you provide an API security solution. Like one size may not fit all, so you need to know your infrastructure, how you're built, to get into more details. Once you have figured it out, the next challenge you get into is API growth. API will grow. What that means is, in breadth, as you can imagine, we have a more problem. The idea is that more and more APIs will grow in breadth. They will also go in depth. That means that API calling API, so there's a lot of chaining going on. And the cardinality of API is also interesting in that sense that if you look on the right side, you have web application, your API gateway, that is your north-south traffic. You hear this word very commonly. And then you also hear east-west. That means that once you're within your infrastructure, what does the communication look like? So the strategy how you apply to do a north-south may not be same as east-west, right? So north-south is the higher cadence. There is a token involved. There's a public coming internet traffic. So, you need to worry about, DOS attacks or bot mitigation at this level. On the east-west traffic, you have a completely different set of problems you need to worry about in terms of how I integrate with my gateway, what kind of system I'm packaging, what are the libraries included in that. So if you continue on that, so this is where I want to spend a few minutes, where now we know that what an API is and what are some of the protocols in there. This is where there's a clear distinction between how API security is practiced within your organization. So, for example, if you're API developer today, mostly you're thinking about client services. What is a developer portal? What is the internal, external? That's how you're thinking. And I'm moving from left to right. And the idea is that the way developers perceive the API security is different from your CISO, who is is responsible for managing your infrastructure is secure, and the APIs you host are not compromised. So if you look at from left to right, the developer is thinking about client services, developer portal, internal, external, management services, how your API manages your API gateways. Similarly, service management, you have platform management. Developers are thinking about that. They're thinking about some analytics services, API analytics and operations, business customer BI kind of scenarios, and similarly security services. And in their mind, they're much more focused upon authentication, authorization, some PCI compliance and single sign-on and those kind of scenarios. But if you look at the bottom line, which is the what API security needs to be thinking is, it's a total different mindset altogether. You need to talk about token channel binding, environment risk, minimize client-side API keys. So the API developer has to be conscious about the bottom row as well when developing the APIs, and that will make sure that you have better practices for API deployment, and then maybe we reduce the risk of API attacks on your organization. So fundamentally, what we're trying to say is just developing the API security. Just developing an API is not enough. You need to be conscious about how your APIs are developed today, not only during development but also runtime. We'll get to that in a bit. So the idea is that you have to be consciously making these choices when during your development process, deployment process, building process, to make sure that your APIs are secure for your organization, whatever business problem you're trying to solve. And we can get into details. I mean, we can have more information. The idea is that each layer needs to have a kind of cadence built into during your API creation process, so that you are taking care of all these things mentioned here, so that you get a better API deployed and your security API security breaches gets minimized. And at high level, if you look at the API security building blocks, there are many building blocks when you're deploying an API. For example, authentication, content inspection. You need to worry about TLS. You need to worry about your digital signatures. What is the usage plan management? What is your quota? What is your throttling? Tokenization of sensitive information. If you're PII, PCI kind of data, what are you doing to protect them within your API calls? And similarly, who is accessing what from where is fundamentally some of the things you need to worry about when developing and deploying these APIs. And these building blocks all are one of the ways they could be attacked or exploited by the malicious users. Any of these exposes your chances of getting infected much higher. So now, if you look at so we talked about how APIs are built, how developers should be thinking about, and what some of the building blocks are. So even now we are switching gears in terms of how attacks have evolved. So if you look at the API attacks now, if you hear the hat of a hacker, traditionally the attacks used to be one and done. That means you find a vulnerable point, you superload them with tons and tons of traffic on that, and you breach it, or you achieve what you're looking for. More recent attacks are slow and slow. Attackers take days, weeks, or even months to probe, learn about APIs, and see how low and slow techniques to follow, and stay under the radar for a while before they launch an attack. So the left and right, left one is like traditional classic case where all your web application firewalls are deployed. They can protect your DDoS kind of scenarios. We can protect it. The recent attacks are tricky. Now you're getting into gray area where your current protections and security in place could be partial. That means that you will be able to protect some of the time, not all of the time, because when you do a low and slow attack, the idea is that you may or may not be detected. And that's where the future attacks and the current attacks getting much more sophisticated. The attackers focus on finding a specific business logic of APIs, because if you look at the current security practices, most of the things you find on 1 and 2, the traditional attacks and recent attacks, you'll always be patching them. You'll try to get ahead of them, try to block them in a way that you get the security you need. But now when you go into the next level, it's all about behavior-based business logic abuse. And this is almost like a new category of attacks hackers are going after, because if you look at the hacker community, they have increased computing power. They can go a larger time. They're much more patient and much more sophisticated. So they can observe an API over a period of time, see what worked, what doesn't work, and be able to get through a tiny precision point where a vulnerable API is found, and that could be your gateway into that enterprise and cause the havoc usually they do. So the idea is that when the API attacks have always evolved, and in the current state of API attacks is much more sophisticated, is much more business logic abuse kind of scenarios. So the development practices and the strategies you develop and the tools you choose also have to be moved on to the next gen of tools that needs to be in there. So now that we talk about API attacks, if you look at the security community, generally you'll see in these categories. If you have attack classes, either it's a DDoS where your network is overwhelmed, or your HTTP flood, and applications are launched by significant amount of data, and you throw large amount of data for a particular API. Hopefully, if they do not have a web application firewall in front of them, servers go down and you get into all the business disruptions. Similarly, the second kind is like a data breach. This is much more impersonation, higher authentication. Customers can. This is a much more known or managed problem in the sense that people have heightened visibility and monitoring about data nowadays. So, probability of getting into that is through API is a little higher, but obviously we need to worry about. And the third one at the bottom is of higher interest for API security practices today, is the abuse and abuse of functionality of business logic. That means that they currently the hackers use the technique wherein they are able to chain an API. They try to make a login attempt. For example, they get something back, and they'll to add a change a URL. They get something back again, and then they will be able to figure out and piece this together as a puzzle. What is that underlying API and how to reach to that. So if you quickly go through, DDoS attacks, it's pretty standard attack. As I said, it's kind of like a wrecking ball. You throw a volume of traffic at a particular API endpoint. You overwhelm the servers, and typically, if you have web application firewall or other places, they will mitigate that. The other kind of DDoS attacks you see is that they are very precision. That means that they narrow down to a particular set of APIs they will be focusing on, and that particular API is overwhelmed with the multiple number of attacks or volume of APIs launched onto them, and they'll try to get through. And this is just some stats. You have a lot of vectors, and where over a period of time, DDoS attacks could be there. Since we provide the web application firewall, we have some data to share. Similarly, what we have to worry about is APIs are susceptible to bot attacks, and the reason is this is a classic example. For example, if you're in a web application, you're always challenged by CAPTCHA. You would say, hey, I could never find which is the, what are the signal blocks to check on. But the idea is that if you have a web application and some APIs underlying it, web application has a way to mitigate the bots, or in a way to say that you are human, and we'll be able to do it. But if you have headless APIs, it is always a challenge because there is no challenge question put in forward. So they could cause a lot of problem, and bots are the primary API target. Now I say you will see a lot of solutions which just deal with bot mitigation, because whenever you have an headless endpoint, more and more volume will be pushed through using bot attacks. And again, these are some stats. A lot of malicious attacks are launched over a period of time for on the internet. And this is an interesting stat. Your bots, when you have a big holiday sale or a specific festivals going on, bots are specifically much more active, where they're trying to get the festival deal or that Nike limited edition shoe. That's where bots are after to get the financial advantage, at the same time create some problems for the application itself. So the third aspect which we talked about is that's where we get into the business logic abuse, and this is where maybe I should have edited OWASP API top 10 is what we should be worried about. The OWASP API top 10 is a specific set of vulnerabilities which are specific to your API. So if you look at that broken access control, there are all these OWASP API top 10. Maybe I got this wrong, so I should fix it. The OWASP API top 10 is a set of well-known vulnerabilities which we need to worry about when you go into the API security. And the idea is that if you do not have a good mitigation strategy or a solution or a tool for them, you might get attacked by some of these examples. I'm sure all of these are well-reputed companies, and they would have done all the right things, but attackers are always ahead of the game. Where if you look at the API vulnerability exploited, that gives you some kind of idea of authentication and authorization seems to be a very common attack vector, where those are easily stolen, and then the loss of reputation, loss of revenue, customer trust, and you can imagine the amount of loss for an enterprise when some of these things happen. So now that we have looked at what are some of the intensity of the API security problem, we looked at how an API is created. We looked at the class of API attacks, DDoS, your bots, and business logic abuse. So, okay, so what do we do with it, right? So now let's get into some solutioning. And if I'm an organization today, how should I think about API security holistically? And what some of the tools and techniques available, and how we get into mitigating them. So if you look into the API security technologies today, this is just list of vendors, and there are a bunch of approaches how an API security solution is delivered. You have code and agent, you have log abstractions and static testing and analysis. So typically on the left, there are a bunch of vendors who can provide you that security. I think uh, let's not get into which vendor. I think the way to look at the API security is you need to have a framework. The idea is that if I am a security practitioner, how do I look about API security? So fundamentally, these are the four pillars you should be thinking through when you're talking about API security: visibility and posture management. Obviously, the first step is API discovery and profiling. You cannot see. If you cannot see, you cannot protect. That's the standard paradigm we use. The idea is that what are my APIs exposed out there? So it's a good to have your inventory, and there is a way should be, whether it's process, and I'll talk in a bit, how to do it in development time and runtime. But the idea is that you should have an inventory of all your APIs, and then worry about misconfigurations. What are some of the things you're doing in there, and some risk management and prioritization in that bucket. The second bucket on the right side you should be worried about is these are all your posture management, in the sense that design development things happening at the top. You not only protect from left, you also protect from right. That means during the runtime, what are some of the things my APIs could be exposed? That means denial of service, automation, injection attacks. So you have standard OWASP attacks, and OWASP API top 10 attacks that you need to be worried about. And you should have some kind of a detection enabled through whatever tool you purchase from many vendors out there. The idea is that on the development side, you're doing some practices and tools. On the runtime, also you're protecting, so make sure that something happens, you have mitigative action in place. And then the bottom is interesting in the sense that you need to do a post analysis where a threat was executed, why that happened. That is very, very important, because you need to know what kind of attacks and what kind of hackers you're attracting, so that you can have a stronger solution in place. So the threat hunting piece is very, very important. So hopefully you are never under attack, but even if you're under attack, you should be constantly analyzing the data to figure out, why some of those malicious users are interested, what data they are trying to go after, and so that you can have a good intervention and integration policy in place so that you can protect that. And once you have all that, you want to put it back, whatever you learned, back into your application development environment, so that you have your security testing is testing for the new things you found, and some of the things you found has been patched, and your CI/CD pipelines are picking up those new fixes, and the cycle goes on. So the idea is that when you are developing an API, you need to have a holistic approach, and the protection should also be holistic, not limited to the area you're practicing. So you need to worry about right from discovery to all the way to patching and all the way to proactive monitoring. So if you rightly break down into who needs to do what, there are two categories of practitioners, right? For example, there is the developer community where they're worried about creating more and more APIs and solving business problem, throwing out more features out for use. And the set of way they should think about API security is a little different from a runtime practitioner. Runtime is usually your CISO or security out front there. Those are constantly monitoring. They're trying to do some heuristics and trying to model some behaviors to see what kind of attacks they're seeing it. So the practice of what to protect in an API will differ from where you sit. The idea is that if you're a developer, you're a different set of problems. So is the libraries scan? Are you following SAS scan, DAS scan properly? Is your CI/CD when bringing in the new containers in? Are you able to confidently say that or digitally sign them so that you're sure that this is the right container going into the production? So a bunch of ways the developers can be doing to protect it, and also not only from your left, you also have from the right. You need to protect on the right as well. So roughly, if you look at that, this is how you can break it out. Your security posture is primarily designed into your design, develop, build, test scenario, wherein at the bottom, before an API gets deployed, you're worried about SAS scanning, DAS scanning, make sure that your code is managed carefully, none of the vulnerabilities get packaged. And once it's deployed to runtime, you are also constantly monitoring. The idea is that once the API in production, the job is not over. API are constantly monitored at runtime to observe, protect, and have and done analysis done for behavior-based detections. And similarly, anything you find runtime attacks like bots and DOS attacks that API should be aware of. So the idea is that when you're talking about API security, you should think full cycle. That's what it's come down to. So it is everybody's responsibility to make sure API is secure. It's not developer, it's not runtime. So the way you think about is, if you have an API discovery solution, discover, detect, alert, and protect is the framework at high level I like to see. So there is a discovery phase wherein your continuous cataloging of APIs done. Your sensitive data has been discovered, your PII data has been marked and identified, and your undocumented APIs and all other shadow APIs have been identified. Similarly, your third-party APIs are identified. The idea is that if you have the inventory, you're able to discover new APIs, you're able to identify the secure sensitive data in there. That gives you good control about what is in my API and how can I protect it. The second aspect of it is, during the runtime, how do we detect attacks? Your OAuth's API top 10 is a standard, give you the standard set of API signatures and vulnerabilities you should be aware of. Similarly, as I showed you, the attacks are evolving over a period of time. Nowadays, attacks are much more behavior-based attacks. That means that they take over a period of time. They look at the API for over a period of time and do some analysis. So you need some AI machine learning kind of techniques in place wherein you are able to detect, build a context around your API, how APIs are chained, and be able to give some protection against it. And after all that, so you discovered APIs, you detected some vulnerabilities, you should have a mitigation strategy as well. So how do you protect it? So however you want to plug that gaps and come up, typically if you're runtime, you plug it in the firewall. If it's not, whatever is the procedure to make sure that you are able to plug those gaps found in that area. And as I said, there is an API discovery and profiling. You need to worry about network. What are network lists, block lists. At network level, what you can do some governance is important. Who controls what. That provide. You need to look at your practices to make sure that you have a good coverage of your authentication and authorization. Similarly, threat assessment. As I said, we need to know what kind of attacks are launched on your APIs. And the right side is very interesting, which is an emerging field. We can talk about it all over again. The idea is that attackers are getting very sophisticated. The mitigation needs to be sophisticated as well. No longer people are overwhelming the networks with a large volume of API calls. They are low and slow. They're observing your APIs over a period of time. And the idea is that they will be able to find vulnerable business logic, and they'll be able to precisely attack those APIs with malicious code, and your enterprise uh, get exposed. So the way to think about your API security is multi-layer approach. Right from the layers you build on your API is very important. This is just an example of how a cloud-based API built in. For example, you need to have your attack surface mapping, visibility of all APIs. You need to worry about if you're deploying in Azure, AWS, or your cloud infrastructure. What are some of the misconfiguration could lead to the API security? Similarly, supply chain attacks. What are some of the things you're packaging in your API? um, are they exposed, or do they have any vulnerabilities? You should be able to be consciously monitoring about that. And the idea is that if you reduce the attack surface, that helps you when your application is when your API is on the internet. The idea is that you reduce it. Similarly, DOS, bot, injection based attacks, these are all common attacks. And fundamentally what I'm trying to communicate over here is you're not one and done. API security needs to be thought in layers. And if you want to protect your APIs, all of these needs to have an action item for making sure that your APIs are protected properly for your organization. So at the end, if not at all, just if we keep it simple, think about full life cycle of APIs for API security solutions. So whatever you buy, it doesn't matter. The idea is that whatever you buy should be thinking about how it impacts the full life cycle deployment, not just development in production, and not only production. If you're mitigated that, how that makes back into development. API security, the standard as like, I try to follow this triangle: discover, detect, and protect. So, you're discovering new API, so your inventory is done. You're detecting vulnerabilities, all the vulnerabilities we talked about, and then how do you do protect it? Because once it's identified, there should be a mitigation strategy right in place. And API security, we should be thought as layered. It's not like it's developers' problem, or the guys who are managing its problem. It should be like everybody should be concerned about what is the exposed surface and how do we want to think about as a full cycle and be able to mitigate that. And once it's deployed, everybody is happy, but we should focus on observability. As I showed you in the Spring Core example, it's not one and done. API attacks are adopting, and malicious actors are figuring out new creative ways to do it. So you should have an observability which is automatically monitoring for new threats. So idea is that you'll be able to identify and follow and put that into the cycle. So at the end, I would like to say, customer expect the digital experience to be consistently fast, consistently engaging, and completely secure. And APIs are at the center of modern experience, and we should do a full life cycle protection for our APIs, not just the areas you operate. That's all I have. With that, I'll stop and see if you have any questions.
That's really awesome, Sudhir. That, there's a lot of really great content in a lot of those slides. And while I open up to the folks that are watching at home, please feel free to send in any questions you may have in the chat. I'll read them out loud and we can have a discussion here about them. But kind of from your position, at Akamai being a third party that has a lot of connections with a lot of different industries and businesses, and you talk about that triangle that you mentioned, was it discover, detect, protect? Of those three pillars, where do you find a lot of mistakes happening right now in terms of securely coding APIs?
Yeah, I think I can just talk from the runtime protection because that's where our expertise is. We can see a lot of data. So the idea is that anytime a wrong API is deployed for whatever reason, we immediately see a lot of thread being executed at runtime because we are like web application firewall. We got any request coming in. We see the spikes in all those graphs you're looking at, and we know that something is wrong. So I think the actual fix for that problem is all the way at the origin, in the sense that maybe during the development process some vulnerability was let in, or some library that was pulled in has a vulnerability in there, and that was being exploited. So as I said, when you look about the full life cycle, the idea is that you need to have a runtime which can immediately mitigate your problem. That means you stop the bleeding at the call, and then you go back and say what happened in there. And usually it's a combination of your deployment or the code you pulled in, or something we left open.
Yeah. Yeah, well, actually, kind of going more on that runtime error.
Mm,
One of the things that security practitioners have a tendency to fall into the trap of is if it's blocked, we ignore it.
mm.
Now, based on what you're saying, having to review the source, the actual code of it, you know, is there merit, like, is there value in reviewing those blocked attempts if there's any patterns in it? How frequently should we be looking at those? I'm assuming it's not at runtime that we need to.
Yeah, so the classic attempt, I showed you the evolution of attacks, right? So what happens is, if you do a slow and low attack, what happens is, on the surface at runtime, the attack looks legitimate. You have a hacker getting into your environment, you would not notice. But we at runtime would have say, hey, I'm seeing little usually high traffic than I'm used to it, so we flag it. So typical mitigation action is at the runtime, there is something called rate limiting. That means that you limit the number of API calls per minute or however you want to configure it. So what we do at runtime is slow it down a little bit, not significantly. But the actual mitigation action is still with the code, right? So somebody needs to take a look at that and be able to provide. So the way we do it is, we classify high, medium, low, like a standard security practice. We send out the alerts to whatever SIM integration, however you want to receive that, and we expect that somebody is looking at there to give some action, like adjust the policy or look at the API and deploy new. But the solution for API, it's not about us saying as a vendor. You have to look at the holistic view, wherein API could be exposed during development. Runtime just gives you a mitigation strategy to avoid the bleeding, but fundamentally the problem has to be solved on the left side to make sure it's done correctly.
Makes a lot of sense. Makes a lot of sense. And it kind of goes back to the point that you made earlier about reintegrating back into the security development lifecycle through the CI/CD process, assuming that you have one, right? What kind of advice do you have for the folks that are still trying to develop that CI/CD flow from the runtime team to those folks that are on the development side? What are some tips and tricks that you can give them as to how to implement those?
Sure. So, I mean, CI/CD is just the new term, and I can imagine like many of our enterprise customers still have, they follow the traditional process of deploying. So the idea is that whenever an code is deployed as an API to the endpoint, the threat vector is much higher. So what you try to do is make sure your SaaS scans are done properly, make sure your DAS scans are done properly, make sure that new libraries, your open source libraries you're pulling in, you have BOM to make sure that you're packaging the right version. So make sure that you're signing your code so that we reduce the unknown vector code getting into. So the idea is that whether you are on-prem or cloud or not having CI/CD, the principles remain the same. That means that you need to have a secure coding practice. Anything you package, we want to make sure that it has been vetted by the actual developers and they are aware of some of the things that it can carry.
Yeah, for sure. For sure. So a lot of these tips and tricks that you're giving have, I'm not necessarily sure, but the folks on this track may be security practitioners. In terms of the way that we communicate that, because at times the folks on that development side and then the folks on that runtime side, me being on the runtime side, as you refer myself, I'm not at the project meetings. I'm not necessarily at the product meetings. I'm not at those updates. You kind of get it downstream. What kind of advice can you give to these blue teams here on this side as to where they should be injected into that, or at what point should those conversations happen?
Yeah, so that's a good point. And so we are seeing a new trend, which is a good trend, is that you are getting into what you call the universal channels. That means that whenever a threat is detected or mitigated at the runtime, there is a corresponding integration to your Slack channels or WhatsApp
Mm.
or however you want to do it, or your Jira ticket. So more and more what you're seeing is, if we determine a threat at the runtime is of high priority, those tickets are automated with automation, are automatically ticketed, and they get into the queues of the people to take idea of. So typically the good way we are seeing
Mm.
is like a Slack channel integration or whatever is your WebEx channel. The idea is that whenever some of these things are found, it gets posted in the channel only the high priority, so that people should be aware, because when you go into the security logs, there will be, small, medium, high, critical. There's always tons of data in there. You can always have a strategy where you pick in the ones you want to act on and publish them on the channel, so that all whoever who developed the API right from are aware of that, and take a look at it. So that's what we do as well, wherein it automatically gets published to some channel, and all everybody who's supposed to be connected with that API gets, oh, something wrong, I need to fix it, or they prioritize it.
Yeah, for sure. And you mentioned this before, integrating directly into the developer's Jira or to the Slack, make sure that it's part of that backlog, that queue of work that needs to happen. What about involving them as part of the incident response? So let's say that something big happens, right? And then you get to the point of an incident response. I would assume that that narrative of the incident, what happened, what are the activities that occurred, how does the API interact with the rest of the attack, I would assume that that's something that developers should also be brought into as well.
Absolutely. So typically, there is always instant response policies across the globe. I mean, every organization is different, but typically what you see is if there is a critical incident, even with spike in volume of a particular API call, there's an automatic a bridge is created where all the concerned 30, 40 people sometimes in that call who are some way or another connected to that gets notified. So now the team, if it's critical, they sit on it, this channel, until that is resolved. And so, it's just more practice and process, because the mitigation has happened wherein, like I said, you can slow down, or sometimes you can block it if it is volume is way high. But the underlying channel has to be immediately created and absorbed, where people are actively looking at it and figuring out why that's happening, and they're logging into their infrastructure looking at it.
Awesome. And I know that Akamai does have its own runtime monitoring process, and I'm assuming that you also do it for API. For those things, do you guys typically recommend a practice of those engagement calls of remediation for high? And then what do you do with the low and informational?
Yeah, so the way typically it happens is critical and high needs to be acted, and every severity has an SLA. That means that critical needs to be done in 24/7, or you don't get off the channel until that's resolved. Then you go to the higher, maybe a couple of days it's not there. And the lower ones, we have a weekly cadence where you go back and see and plow through all of them and mark them and say, this is something you need to worry about. Or, okay, we know about it. It should be in the roadmap for the next release. So you have to act on all the things you find, and the cadence is different. So some things you act right away, and then based on your priority and the processes, you spread it out.
Yeah, for sure. All great tips there. Really appreciate you taking the time with us, Sudhir. Folks on the comments, I think I didn't see any. Let me just check right now to see if there's been any questions, and none so far. Really fantastic. If anybody wants to get a hold of you, Sudhir, for any questions, how do they reach out? Oh, you're muted, I think.
Yeah, Chepeni@akamai.com, and I'll put it in the private channel as well, so that you can publish.
Okay. All right. So thank you so much, Sudhir.